Did you know that some plants can naturally provide color and do so sustainably? Autochthonous dyeing plants, whether wild or cultivated, not only support biodiversity but also offer new opportunities to local farmers. But that's just the beginning. Natural dyes can also come from agricultural byproducts, a great example of upcycling in action. By transforming what's usually discarded into a valuable resource, we reduce waste and give new life to raw plant material. Using natural pigments in the dyeing process means embracing a more eco-friendly alternative to traditional industrial methods. And when every part of a plant is used, from root to leaf, a full value chain is created, one that's circular, efficient, and collaborative. This circular ecosystem connects nature, producers, consumers, and even waste recycling, forming a regenerative loop that starts and ends with the earth. Let's explore this further through an example. Let's talk about woad, a fascinating flowering plant from the mustard family, known for its deep historical role in dyeing and medicine. Woad has been used for centuries as a natural source of blue dye, long before synthetic alternatives appeared. Native to the steppe and desert regions stretching from the Caucasus and Central Asia to eastern Siberia and Western Asia, woad now also grows in parts of Europe and North America. In Switzerland, for example, it can be found growing wild in the canton of Valais. In ancient and medieval Europe, woad was a major crop, especially in western and southern regions. Towns like Toulouse thrived thanks to the woad trade. Its dyes were highly valued for their color-fast properties on both plant and animal fibers. Over time, woad was gradually replaced by Indigo tinctoria, a plant that produced a stronger, longer-lasting blue. And by the 20th century, both were overshadowed by synthetic dyes. Still, woad remains an important part of our botanical heritage, not only for its vibrant pigment, but also for its medicinal uses, known and applied for centuries. This plant thrives in hot and dry climates, making it a perfect example of how native species can align with sustainable, local production practices. Now, let's walk through the process step by step. We begin by harvesting around 30 kilograms of freshly collected aerial parts from Isatis Tinctoria plants, whether grown in the wild or cultivated. This first step is essential. Careful selection and handling ensure the quality and potency of the raw material, setting the stage for the next phases of the process. The better the harvest, the higher the yield and the stronger the properties of the final product. To prepare your herbs or leafy greens, carefully separate the leaves from the stems. Hold the stem firmly and gently pull off the leaves, discarding any tough or woody parts. Flowers do not hinder the process and can be left in. This process ensures you're left with just the tender, flavorful leaves, perfect for your culinary needs, enhancing the taste of your dishes. Next, it's time to prepare the mixture. Add demineralized water at a ratio of 1 part plant to 5 parts water. This ensures proper hydration while avoiding any minerals that could interfere with the process. Mix thoroughly. This step is key to activating the beneficial properties of the plant material. You can adjust the quantities depending on your batch size or specific needs. Now, acidify pH to below 4.0. This level of acidity is essential to create the right chemical conditions for the process. Once mixed, let it macerate overnight at room temperature. This resting time allows the ingredients to blend, activate, and release their full potential, enhancing the quality and effectiveness of the final product. Now it's time to use the package press, a key tool for ensuring consistency and quality in the final product. By applying controlled pressure, the materials are compacted and sealed evenly, helping to preserve their shape and integrity. This step is essential to make sure the product remains stable during both storage and transport. The filtration process plays a vital role in ensuring the removal of particles larger than 1 micron. This step increases the purity of the solution, preventing unwanted contaminants from interfering with the next phases. Using the right type of filter ensures both efficiency and precision, preserving the integrity of the final product while achieving optimal clarity. Next, the solution is basified to pH above 10. This increase in alkalinity creates the ideal conditions for key chemical reactions to take place. After adjusting the pH, it's important to aerate the mixture to ensure proper oxygenation. Finally, let the solution settle overnight. This allows any remaining solids to separate naturally, resulting in a clearer and more stable product. At this stage, the focus shifts to sedimentation, a simple but essential technique. Here, the precipitated indigo naturally settles at the bottom of the container, separating from the liquid above. Once the settling is complete, the clear liquid can be gently removed, leaving behind the concentrated indigo, ready for further processing and purification. Now, proceed with Buchner filtration to separate the solid indigo from the remaining liquid. Once filtered, wash the collected solid with alcohol. This step helps eliminate residual impurities and enhances the overall purity of the sample. By carefully performing this process, you ensure a cleaner result and improve the quality of the final product. The final stage is the recovery of the indigo paste, which involves a few essential steps. First, the paste is carefully dried to eliminate any remaining moisture. Once fully dried, it's ground into a fine, uniform powder, making it easier to handle and use. Finally, the processed indigo is securely packaged, ready for distribution and application across a variety of uses, while preserving its quality and stability. Through this step-by-step process, we've seen how natural indigo can be recovered and transformed using methods that respect both tradition and sustainability. By combining botanical knowledge, careful handling, and low-impact techniques, we not only obtain a high-quality pigment but also contribute to a more circular and conscious approach to textile dyeing. A small plant, a long history, and a powerful future for color.